Question 22. How many four-digit numbers, all of the digits different, can be formed from the digits 0 to 7 if there must be a 6 in the number? Okay, this one here can be a little bit tricky because if we want to make sure that there is a 6 in the number, it could either be in the first spot, the second spot, the third spot, or the fourth spot. So all the digits have to be different, so those are the only four options. We could break it down into four cases, or we could do this as an indirect problem and just say, let's forget about the fact that there has to be a 6 in it and just say how many numbers are there. Maybe they have a 6, maybe they don't. So we have a four-digit number using 0 through 7. First number can't be 0. So we have 7 options there. And since the numbers now have to be different, the second number can be any of the 8 except the first number. So we got 7 there, 6, and 5. And when we put that all together, again, I could write that as a permutation if I wanted to, but I think that's probably overkill at this point. It's just 1470. There may be a 6 in there. We don't know. There may be a 6, but there doesn't have to be. Now what I'm going to do is figure out how many ways I can do this with no 6s. So 6 is just not one of the options. Okay, so this one's not a 0, and none of them have 6. Okay, so 0 through 7 really now is 0 through 5 and 7, so that gives us 7 possible numbers. The first one has 7 possible numbers, but not 0, so there's 6 possible numbers. The second number is 7 possible numbers, but not the first, so it's going to be 6, this is 5, and this is 4. That's 36 times 20 is 720. And these are numbers that have no 6. And now if we take all of the possible numbers and we subtract off all of the ones that have no 6s in them, the ones that are remaining definitely have 6s. So that's 1470 minus 720, and that should be 750 possible numbers. So you can try this directly. It's not actually that much harder, but indirect happens to be a pretty quick way of getting this one.